In this video, I'm going to show you how you can batch process images with Annotater and extract features. So let's say, we're back with this image. We have the nuclei that were segmented. We have the different regions, and already there you can have some measurements. If you hit measurements, so you see you have a different, so let's go back because here it went too fast. It's gonna save the measurement associated with the nuclei as defined here in set measurements. So here you need to define the features you want to be associated with your nuclei. So here to me, area, mean gray value, and centroid is perfect. I don't need the display, so I'm just gonna hit OK, and then I can do measurements. So basically it goes through your ROI, and you see you have, for all your nuclei, you get the area, the average nuclear component for channel 1, 2, and 3, the centroids, X and Y. And then you also have, because here we have the region, so if you go, you have the region class, so 2 and 1. So 2 for mesenchymal cells and 1 for the epithelial cells. Okay, now let's define, let's focus on actually on the PHP and try to define them with a machine learning approach with the logistic regression. And as I told you in the previous video, we have two different patterns. We have the diffuse and the punctate. So let's define two different markers, and then we'll see how we can deal with that. So let's go through it. It's a nuclear marker. It's going to be a machine learning, and it's going to be defined in channel 1. Okay, so I'm going to so if I want to have the diffuse, so we don't have, so here it's going to be just a bit tricky with the diffuse because we don't have that many. So I define negative as punctate or nothing. Let's train it and see what it gives. So here we have way too many positive nuclei. So I'm going to have to define again more negative nuclei. This as well. Let's try it again. And here I think it's fine. So I'm not sure it's gonna work on others. No, I'm messed. Forgot this one. So here it's not very convenient because we had to define all of them manually. But you know, if we do it on a batch of images, it's gonna be better. And let's define another marker. Again, nuclear marker, again, machine learning, again, channel 1. But now we're going to define the punctate. So positive is going to be these guys, and negative is going to be this guys, and also negative ones. And so here, you know, it seems to work pretty fine, but we are missing some. So let's define. So here it might be tricky, but we'll see. Yeah, so now we have way too many. So that's, you know, that's pretty common. Sometimes you just have a few steps to go over to make sure it works. This might be tricky as well. Yeah, I'm gonna remove it because it's just because you have a pause and it looks like punctate even though it's not. It's just, I guess if you look, yeah, there was no DAPI, so no nucleus was defined. But if you look at the PHP, there was something like diffuse here. So let's define it that way. So before doing anything else, we can also do measurements. So it's going to work the same way with the measurements we had, but now we have markers. So let's do it. So same thing as before, we have a region as well, but we also have marker 1 and marker 2. So 0, there's nothing, and you have the ones that are positive. So this nucleus is positive for marker 2, so it's a punctate. And let's try to find a diffuse one here. So you see here you have all the features you want to extract from your image. Let's have a look at the snapshot. I didn't show it for the other one. So if we do it on this one, you see here it shows you a summary of your images, and it shows that actually we have a marker that is positive for both of them, and I haven't seen that. Yeah, so this one is actually positive for both of them, and here it should be negative. So let's train it again and see. We are missing some, so I'm gonna just add a few ones. All right, so now it should be better. Yeah, so you see you have a positive nuclei for diffuse pH3, the other ones for punctate pH3, and you have your regions. Okay, so that's more like a visual inspection of your results. If you go back to object annotation, you can also do a snapshot, and here it's more to have, so you can do it with objects. So if you want to show the segmentation in a presentation in a figure, for example, I think you can also add the regions, but here it might be confusing. It depends. So you have everything here. All right, so now let's try to apply this to a batch of images and using the batch. So we're in the marker annotation, we use a batch. And now we're going to go through a series of questions. So first, do you want to batch process marker associated objects? Yes, that's what we want. We want to actually apply this classifier to other image. So it might be here, you know, here's just for the example, I don't want it to be too long, but I would, before doing that, I would advise to load another couple of image and segmentation and see if the classifiers are working fine with the other ones as well. But we're not going to do it to go fast, so yes. Then I want to define them with what I defined. You could have images, so if you were to have saved markers identification from previous analysis, you can use it as well. But if you want to use the classifier you define, that's what you want to do. Do you want to add image to define areas? So yes, because I want to have the information here which correspond to epithelium and mesenchymal cells. Do you want to batch process result image for visual inspection? So that's what I was showing. Yes, I want to have this too. And now I have all these folders to define. So first, image folder, which corresponds to the images. Okay. So I'm going to select this one if I can. I'm going to use my touchpad to do it. Okay. The object segmentation are defined in the segmentation folder, and the regions in the regions folder. Okay. Now I want to define marker associated objects, so that's for visual inspection. I'm going to define another folder, markers, marker associated objects. Okay, measurements, that's where all the features will be defined. So I'm gonna actually just call it results. And finally, result image folder, where we'll have so I'm sorry, here I made a mistake. Marker associated object folder is going to be the marker that are associated and save as if I were to save them here. So it's going to be, it's going to define all the marker associated nuclei and images. And finally, this is the visual inspection, so I'm going to define a new folder as result images, for example. Okay. And you have one thing that tells you which markers are incompatible, and here it's actually useful because we know that PHP cannot be punctate and diffuse at the same time. So let's say that we don't want the punctate to be diffuse, so everything that is both punctate and diffuse is going to be diffuse, actually, I guess, in that case. And do you want to add a combination of markers? So here it doesn't make sense because we have only 2 markers and they don't overlap. That can be very useful if you have, if you look at immune cells and you can identify them as a combination of 2 or 3 markers, for example. So you could, if you do that, I'm going to do it just for the example. So you first define it. So here I'm going to say PH3 diffuse, and then you can define a combination. So I could say 1 and 2 again, doesn't make sense, and PH3 diffuse is marker 1. But if you were to have specific cell types that correspond to a combination of markers, that's how you could do it, and then you only extract the combination of markers that are interesting, which can be one, several combination of markers. And so when you have defined all the combinations of markers you're interested in, you can just hit no, and now it's going to batch process. So basically it's loading the images and the segmentation and the regions, and then applying the logistic regression to define the markers. And it's doing it for each image. So here we have 4 images. So I did the first image and now the second. So now you see it's not that long, but I'm just going to speed up the video so you don't have to wait for everything. All right, now it's down. So I can, sorry. So here you have final results, but we saved everything here, so I can just open it and you can have a look. So images, regions, and segmentation were what we had before. Marker associated objects are the marker that were defined with the classifier. So for this particular image, the diffuse and the punctate, you can do it. So you can, if you want to go back to your images, you can check which nuclei were defined as so identify as associated with those markers. And finally, you can go to the results. And so you have, for each of your image, all the different features: area, average intensity in channel 1, nuclear component, and channel 2 and channel 3. Yeah, so here let's open it with Excel. It's going to be easier. Channel 1 to 3, centroids, and then regions, so 2 1, marker 1, marker 2, and PHP diffuse. So this is going to be, this is, yeah, you see, so it's the same than this one because we defined it as just marker 1. And so you have all your results that are saved here. And you also have the areas, which can be useful if you want to know what area of your image is in region 1 and in region 2. And so you have it for every single image that was batch processed.